Okay, so how do we use momentum? So one way that we use momentum was in an isolated system, and then another way was in a non-isolated system. So when you have an isolated system, the change in momentum is equal to 0. So that's to say that, P final minus P initial, which is the change in momentum, is equal to 0, or we could rearrange that and say P initial equals P final. And we use this in a few different situations where the system was isolated. So there's out when you're in space, like sapling problems where somebody had a wrench and they threw it, and then you'd figure out from the wrench's speed how far, the astronaut's moving. We had 2D situations on ice, like a warthog and a lioness, where they're functionally isolated. And then we had situations where we had, collisions where we considered the system to be, these two balls, which maybe they're moving toward each other, and then, a moment later, we have them moving away from each other. And so in all of these situations, we had, an isolated system. Now, we have a non-isolated system, what are some examples there? So some examples there are, one was, we thought about, a cannon that was shooting a person out of it, right? So here's our cannon, and then we have a person that's being shot out of the cannon, and they're landing in, a net over here, and we basically figured out, based on the change in momentum, why the net was more appropriate to land in than just land in on the floor. And then we can also have collisions where one of the things colliding isn't part of the system, right? So we had baseball bat, and a ball that would hit a baseball bat, and then later it would bounce off the baseball bat. And since the bat isn't part of the system, we can say that the ball had some change in momentum, and then there was some force acting. And so in these situations, what we would do is we'd find the change in the momentum of, say, the person or the ball by looking at the external force, the force acting on that, and integrating it over time, right? So if the force changed in time, we'd have to integrate the function of the force as a function of time. So there are situations where maybe we know the average, so this is, the average net force on our object, on our ball or person, or, this could be, if the force is constant, we just put a constant force there, and that's how we find our impulse or our change in momentum of the object.